So we can choose frequency of the local oscillator as Fw minus Fc or Fc minus W, right? So if the frequency, the desired frequency where we want to shift our frequency, our wideband signal is higher than Fc, then we can choose your local oscillator frequency as Fw minus Fc. Otherwise, we will choose FLO as Fc minus Fw. So when we choose FLO as Fw minus Fc, what would be the output of your multiplier circuit? This X1T. This will be, just you have to replace your FLO with Fw minus Fc, right? So what we are doing effectively, we are replacing your Fc plus FLO by Fw in first case. So our X1T will be AC by 2 cos 2 pi Fwt plus CFAT. This is first cosine and the other cosine is cos of, since we are replacing your FLO as Fw minus Fc, FLO as Fw minus Fc, that will be 2 Fc minus Fw, 2 pi 2 Fc minus Fw t plus C of t. So if we put a band pass filter which is centered at frequency Fw, then we will get this signal and this signal will be discarded. So we have to then pass it through a band pass filter at center frequency Fw. It is a band pass filter. There is no need to draw it, you understand it. We pass it through a band pass filter centered frequency Fw. So this will be discarded and you will get only this term. So it will neglect. And in the second case, we can choose FLO as Fc minus Fw. Then our output signal will be AC by 2 cos of, your FLO is Fc minus Fw. So 2 Fc minus Fw, of course there will be a factor of 2 pi plus C of AT plus cos of 2 pi Fwt plus C of AT. It is simple to see, very easy. So if we then pass it through a band pass filter centered frequency Fw, it will go away and we will only have this. So now what we see that we have now shifted our FM signal. We have shifted our FM signal to a frequency, center frequency at Fw, and we have not touched the frequency deviation. The frequency deviation is the same. So this operation, there is one interesting point to notice here, that since you are passing it through a band pass filter, so if these are two cosine terms, okay, this is 2 FM signal rather. So this FM signal will have some bandwidth around 2fc minus fw. So if it is 2fc minus fw, so it will have some bandwidth, right? Though ideally it is infinite, but most of the bandwidth, if you remember, this is the bandwidth. Carson's formula you know. So there will be some bandwidth corresponding to this. Similarly, if it is fw here, there will be some bandwidth in this, right? So what we have to make sure that these two frequencies are far apart so that the spectrum of these two does not overlap. The bandwidth of these two signals does not overlap. Then only we can properly receive only this signal. Otherwise, some vestige or some part of this signal will also be there. So we have to make sure that 2fc minus fw is quite far from the. So if bandwidth is w, in so we have to make sure that this w is so fw plus w is such that it is less than this value 2fc minus fw plus this spectrum. Just I am telling, this is interesting thing, you should know that fw and 2fc minus w should be far apart. For this case, when we use FLO as fc minus fw. Similarly, if you use FLO as fw minus fc, fw and 2fc minus w, sorry, this we have discussed for this case, and I think yeah, we have discussed both the cases, like 2fc minus fw should be quite far from that. Okay, so the operation of frequency mixing or conversion, also known as heterodyning, right? So it, what does it do? It shifted the spectra by an additional FLO, right? That we have seen. So as I discussed here, you can choose these two FLO and accordingly you can do. And one important point is that it shifted the frequency, but no change in frequency deviation. So this point should remember. So next we will discuss that what are the distortion which is inherent in indirect or Armstrong method. If you remember that our NBFM signal has some amplitude distortion, right, amplitude variation that we took care by band pass limiter. So since we are using the NBFM signal in order to generate our band pass wideband signal by using frequency multiplier, so whatever distortion we get here, they will be inherent in the wideband signal, right? We will get what we get here, wideband FM signal. So we will discuss it in the next class.